NEET 2025 didn't go as planned.
535 marks.
बस थोड़े से मार्क्स से रह गई। बायोलॉजी ठीक था, केमिस्ट्री भी, पर फिजिक्स वो फिसल गया। इस बार पढ़ाई नहीं, तैयारी करो, वो भी स्मार्ट तरीके से, क्योंकि इन्फिनिटी लर्न लाए हैं अट्रेया, इंडियाज मोस्ट पावरफुल नीट रिपीटर्स प्रोग्राम विद P² CB, जिससे फिजिक्स पे होगा डबल फोकस।
Don't just make it your last try, make it your best one yet. Join Infinity Learn today.
Hello my dear students, good afternoon, welcome to one more amazing session from Infinity Learn by Sri Chaitanya Academy. This is Suresh, Faculty of Chemistry. So how are you all able to hear me? Please confirm. Please confirm. You're all able to hear me and you're all able to see me? Yes. Today's topic of interest is going to be chemical bonding and the bond parameters. In that bond parameters, we are going to discuss about all bond length and bond energy, bond angles and dipole moment, hydrogen bonding and metallic bonding. These are the various points where you are going to connect with the total inorganic chemistry will be given. Yeah. So please confirm you can hear me. So is there any voice interface problem you just mentioned this? Okay. So bachcho, in this chemical bonding you are going to see the bond parameters will come across with intermolecular forces as well. So before going for this, I just want to take you, this session is very important for the total backbone of the inorganic chemistry. In the total backbone of the inorganic chemistry, my dear students, what I can say here, total P block elements and D and F block elements and molecular geometries and everything is connected. And this particular session is useful for those who dropped your 12th grade and reappearing for NEET examination. You can get a benefit of this session, and those who are preparing and attending the classes even in the 11th standard, because this chemical bonding, this part is going to be related to the 11th standard, and also you can have this class those who are in the 12th standard as well. So it is a universal session for those who are 11th and 12th and the droppers also. Before going for these details, I just want to tell you, Infinity Learn and Sri Chaitanya Academy is introducing the most powerful preparation package, that is Atreya program. And in this Atreya, we want to take it as a special program for the NEET droppers. So we will transform you from I didn't do to I will do. फिलहाल कुछ नहीं कर पाए, आगे करने को आपको अच्छा तरफ कोचिंग देना चाहता हूँ. Yes, this is an Atreya program. In this Atreya program, you can see India's most revolutionizing program where you can come up with P² CB program. In this P² CB program, you have double preparation for physics along with chemistry and biology. As you know, when 2025 NEET examination happened, biology ठीक ठाक था, chemistry भी अच्छा गया, लेकिन physics it is given slap like anything. That's the reason why we want to transform the situation from I didn't do to I will do. So we are doing a lot of hard work for the total students. We want to make you to say the physics is going to be on us, and you will say physics is no more difficulty and it is going to be very good and interesting topic. And for that we are preparing P² CB program, and the link is available in the description box. You please click that link and follow that. And so the details of this course is going to be, it started May 23 and every week a new batches has been given. So if you join, you're going to enroll in the new batch, and the classes will be from Monday to Saturday. Sunday ko kuch chotti hai, and you can say every day you have 3 sessions and 2 concept sessions and 1 is going to be practice session. So each session is going to be 90 minutes students, 1 or 30 minutes, and in that 18 classes per week, in that you have a double practice class for physics along with a senior faculty member. And why late? And link is available in the description box. You can just click it and enjoy this. And also in the total program of this Atreya, you will be having 465 classes, and you will be having 240 DPPs and a dedicated practice class around 120 plus and more than that also. And after session, the revision notes will be given in the portal. And you can see this is very, very important. The batch size for the practice classes is going to be just 20 to 25. How important it is. If you are in the practice session 1 in hundreds, you can't practice it properly. If you are in a small batch like 20 to 25, you can have a chance to interact with your senior faculty, and a customized doubt clarification is also possible. So don't miss this chance. Total 11th and 12th syllabus is going to be covered here. Those who are in the live session, please like this session and subscribe to Infinity Learn NEET YouTube channel, so that we'll do it. And after this, just once you got the rank and you got it, and fill in the details so that you will be counseling where you are going to get a seat and which medical college is probably are going to enter. So that find your dream top medical colleges. A link is available. This also you can just click it and go ahead with us. So no worries, promotion is over. Let us go into the content. And hydrogen bond. So hydrogen bond is a super important parameter which decides the and which changes the total behavior of the molecule. Just like a water, you have a hydrogen bonding. And you see, I will tell you, you take a water in 2 glasses, 2 beakers, and in one beaker ammonia is bubbled and another beaker phosphine is bubbled. So what happened? So when the phosphine PHE3 is bubbled, the bubbles can be seen. While ammonia is passed through it, you don't see bubbles. So when the gas is passed through the water, bubbles are not seen. How it is possible? Yes, phosphine is passed, PHE3 is passed through water. What happens? Phosphine is insoluble in water, so it comes as a bubble. While you can say ammonia is soluble in water because of intermolecular hydrogen bonding. Ammonia forms hydrogen bonding with water. As a result of this, ammonia is going to extensively soluble in water in any proportion. So magically what happens when the ammonia is passed through water, bubbles are invisible. Can you believe it? Yes, that is due to hydrogen bonding. So we will start with hydrogen bonding and we'll go into the details about the hydrogen bonding. So displacement of electron towards X. So when an element X and hydrogen is linked, due to the electronegativity difference, it is going to have a partial negative charge, it is going to have a partial positive charge. And this makes the bond is more polar, so the polarity is seen. And due to that polarity, you can have the hydrogen, and that is a dipole-dipole type of interaction, and hydrogen bond is represented by a dotted line ताकि आपको जैसे hydrogen to fluorine, you can see here hydrogen to fluorine and hydrogen to fluorine, and there is a partial negative charge and partial positive charge. There is a partial negative charge and a partial positive charge. So there partial negative charge, partial positive charge बीच में कुछ attractive forces होगा. That weak attractive forces that appears between the partial positive charge hydrogen and partial negative charged electronegative atom like oxygen, hydrogen and nitrogen, and that bond is called as hydrogen bond. Okay, please. Can you all able to hear me? Just give a thumbs up and fire emoji in the chat box. Let us go ahead with the details. Okay, 1 minute please. And this bond, dear children, this bond is called as a hydrogen bond, and this hydrogen bond is represented by dotted lines. 3 to 10 kilocalories the bond energy. So for the hydrogen bond, special case of dipole-dipole interaction. Hydrogen bond is a special case of dipole-dipole interaction. And what is the meaning of this? Dipole means there are two poles that appear on the molecule. Yeah, okay. What is Ho? Okay, so you tell me if you have. Kya padna raha hai? It is about hydrogen bonding, and this is a dipole. Bachcho, this is a dipole, and this is a dipole, and the bond between these two dipoles, dipole के बीच में कुछ bond है, उसमें hydrogen involve कर रहे हैं, ये hydrogen bond होगा. Hi. And let us say no spamming in the chat box. Please follow the lesson, because बच्चों के लिए कुछ भला करने का हम कोशिश कर रहे हैं ना. Okay, please take this advantage and follow this, and please maintain the chart decorum, and chart पे बदमाशी मत करना. So अगर आपको कुछ डाउट है ना, तो चार्ट बॉक्स इस्तेमाल करके आप पूछना, and I am going to honor every question that is been asked. Hydrogen bond is a special case of dipole-dipole interaction, and the molecule with hydrogen atom attached to highly electronegative atom. कौन सा होगा? It could be oxygen, or it could be nitrogen, or it could be fluorine. Only these three elements are eligible for making hydrogen bonding. And you can see the attractive force which bind hydrogen atom with one of the electronegative atoms like fluorine, oxygen, nitrogen, sometimes rarely with chlorine, which is very rare in the case, and of another molecule. You can see hydrogen and fluorine and hydrogen and fluorine. Okay, and there is a dipole here, negative charge and a positive charge, and a negative charge and a positive charge. ये दोनों का बीच में कुछ होता है ना, that is what is called as a hydrogen bonding, the attraction between the negative charge and a positive charge, right? And also I just want to give you one more example, beta. Oxygen with the water molecule, this is the structure, and the water molecule, there is a partial negative charge and a partial positive charge. Here partial negative charge and a partial positive charge, and a partial negative charge and a partial positive charge. And the attraction forces between these two, is the hydrogen bonding. Yes, it is a, whenever hydrogen bond comes now, even in the organic chemistry, you are going to be getting a special behavior. All the electronic effects you study in the general organic chemistry, maybe inductive effect, electromeric effect, mesomeric effect, and aromatic effect, everything is overtaken by the hydrogen bonding. Hydrogen bonding effect is the strongest effect while you decide any electronic effect. That's very important. Okay, Rushan, and let us see the main condition for the hydrogen bonding. Does every element that is attached to hydrogen can form hydrogen bonding? No. The hydrogen attached to an electronegative atom. So that electronegative atom should be very small and its electronegativity should be very high, ताकि इसका hydrogen form करने का condition satisfy करता है. So इसके लिए electronegativity of the atom to be small, it should be small enough, and like oxygen, fluorine and nitrogen participate in the hydrogen bonding, not any other elements. So that when you see the relative strength of various bonds, you know hydrogen bond is the weakest bond among all the bonds. It's a kind of van der Waals bond. So you have van der Waals forces of intermolecular forces are there. So among all van der Waals forces, hydrogen bond is the strongest bond, my dear students. And so ionic bond is more stronger than covalent bond is more stronger than hydrogen bonding, right? And also you can see, so very strong hydrogen bonding occurs with alkali metals. And hydrogen fluoride, the formula MHF2, because hydrogen fluoride has its intermolecular hydrogen bonding. Okay. Hi, Vivan Tripathi. You have KHF2 is existed. NaHF2 is not existed. Hi, Vivan Tripathi. Hope you understand. If you have any doubts, use the chat box and you can ask us. Which of the following hydrogen bond is the strongest? This is how NEET examinations question can come. Can you believe? Can you answer anybody who are there in the live? Please, anybody who are there in the live, you can answer this. More the electronegativity, stronger is the bond. So that oxygen, hydrogen to oxygen, hydrogen to fluorine, hydrogen to hydrogen bond nahi hoga. Hydrogen to nitrogen, electronegativity, fluorine is greater than oxygen is greater than nitrogen. So जहाँ पर fluorine है इसका strong hydrogen bonding होगा, right? So similarly we have arrange the following in correct order of their hydrogen bond strength. Same thing. Same thing. You can see the again you can say oxygen, hydrogen, oxygen, oxygen, hydrogen, nitrogen. So that I can say oxygen is more hydrogen bonding between hydrogen, oxygen. So C is going to be more than D is going to be more than A is going to be more than here B. Nitrogen will be the least, right? Nitrogen will be the least. So this is how you are going to see the questions from the NEET examination. So whenever you study a concept, you understand and what way the question can be asked in what corner. So we are from the faculties, senior faculties from the Infinity Learn, and we are giving you the best content related to the NEET examination. Use these sessions and you can do the best. Okay, dear students, I want to say we have two types of hydrogen bonding. One is intermolecular hydrogen bonding and intramolecular hydrogen bonding. What is the meaning of intermolecular hydrogen bonding? So intermolecular hydrogen bonding means the hydrogen bonding that exists between two molecules is called intermolecular hydrogen bonding. Whereas intramolecular hydrogen bonding is the hydrogen bonding within the molecule is called as intramolecular hydrogen bonding. You can see homo intermolecular, hetero intermolecular. I mean to say the hydrogen bonding exists between two similar molecules like water. So water molecule is going to form hydrogen bonding with neighboring water molecule is called homo intermolecular for hydrogen bonding. Vivan Tripathi, and you can see here hetero intermolecular force, the water and the alcohol is added together. So what happened? There will be a hydrogen bonding between water and alcohol. That is what is called as hetero intermolecular hydrogen bonding is very important. And you can see examples of intermolecular hydrogen bonding. So water molecule and water molecule, you can see here, I just want to write here oxygen, hydrogen, hydrogen, hydrogen and oxygen and hydrogen. There is a partial negative charge, partial positive charge, negative charge and a positive charge. In this case, you are going to have the partial negative charge 2 magnitude will be there, and there is a hydrogen bond between these two. This is what is called as intermolecular hydrogen bonding. So the hydrogen bonding exists between two neighboring molecules. So the positive charged hydrogen of one molecule is going to have a weak electrostatic force of attraction between the more electronegative atom of the neighboring molecule is, say it is an intermolecular hydrogen bonding. So in the solid state, in liquid state, hydrogen fluoride is going to have the intermolecular hydrogen bonding. So this is HF molecule, this is HF molecule, right? And you are going to see the hydrogen bond between these two. So that as a result of this, you can see HF exists as zigzag polymeric structure. So in the vapor state, HF exists as H2F2, and in the solid state it is going to exist as HF n times. So this extensive hydrogen bonding gives you the special properties for the second period element in the periodic table. Yes, I say it is connection. The studying inorganic chemistry require the periodic table and the chemical bonding, and these two is going to be the driving force for your total inorganic chemistry journey. So the total NEET examination, you have 45 questions from the chemistry, which has near about 15. So physical, organic and inorganic. So when you study well, these 15 questions from your NEET examination is from inorganic chemistry. Definitely you can do it. Very simple. And in our classes, I am going to tell you how to add up 4 marks in each day. So this is the magic in your preparation, my dear children. It's very important. Okay, Vivan, like the session, and all the students who are online, please like the session, and when you click the like button, it will be visible to me, so that energy of the session is going to be increased. And if you have any doubt, use the chat box and can discuss with me, so that any kind of doubts I just want to make you to clear. And to have this kind of awesome sessions, you need to go to the coaching centers and may pay huge amount of money, travel for 1 or 2 hours in the traffic. So all things are zero now. You need not have to pay anything. These classes are full free of cost, and you can sit at home without wasting time. And if it is a dropper, you just take it and you can clear NEET examination with a lot of confidence. Your confidence is on us. Definitely we can help you. And you may think that NEET YouTube classes pakad ke kar sakte, and you just see so many success stories are there when you attend the NEET YouTube channel. So from us, so many students in this year and the last year also, so many students got NEET seats and medical seats. And you are not only you're going to get a medical seat, but also you can be a topper as well. Yes, it is true. Yes, Vivan, come on, let us see. You can see example of intermolecular hydrogen bonding. Actually, when acetic acid is dissolved in the water, it is going to ionize. So CH3, COOH, not only acetic acid, any carboxylic acid, when you dissolve in the water, it is going to ionize to give CH3 acetate, and H plus is given. Now, but what happens when you dissolve acetic acid in benzene? It is going to dimerize. It is going to dimerize, so that it is going to get CH3COOH twice. How it is explained? You can look at this. Chemistry is so easy. I'll tell you how to do this. Acetic acid actual structure comes like this. Acetic acid actual structure comes like this, and it is neighboring acetic acid molecule CH3, C double bond O and OH. And there is an intermolecular hydrogen bonding can be seen. There is an intermolecular hydrogen bonding can be seen like this. So this is a dimer. You can see the benzoic acid, you can see acetic acid, you can see anything behaves like this. The key point is going to be here benzene. If you dissolve in the benzene, okay, C6H6 is the solvent, its behavior is this. And this particular point can help you in deciding what factor in solutions and colligative properties. मैं क्या बोलना चाहता हूँ, जो हाइड्रोजन बॉन्ड है ना, ये इनऑर्गेनिक केमिस्ट्री में इम्पॉर्टेंट है, ऑर्गेनिक केमिस्ट्री में इम्पॉर्टेंट, फिजिकल केमिस्ट्री को भी कनेक्टेड है. It is going to impact physical properties as well. So बच्चों आगे बढ़ते हैं. आप क्या करना है, अगर कुछ डाउट है ना तो जल्दी बोलना, जल्दी विवान. And example of intermolecular hydrogen bonding, you can see P block elements, boric acid. In this boric acid you can see बच्चों H3BO3. So H3BO3 is a boric acid. इसका structure आता है ना, boron, okay, and it is going to be OH, and it is going to be OH, and it is going to be OH. Now you can extend its hydrogen bonding like this. You can extend its hydrogen bonding like this. Okay, it is going to have extensive hydrogen bonding, so that hexagonal sheet like structure is there. Boric acid in the crystalline state, because of the sheet like structure bacho, when boric acid is touched, because of this sheet like structure, one sheet slide over the another sheet, so that boric acid, when you touch it, it is slippery, smooth surface. That is the reason why it is used in as a smoothing agent when you play carom board. Where you all play carom board na? You like the carom board? Yes. We will play with this and we can do it. So example of intermolecular hydrogen bonding यहाँ पे भी कर सकते हैं. Like you can see the water, alcohol. When alcohol is taken, you have intermolecular forces. So you can see here, water is soluble, alcohol is soluble in the water. This is your water and this is your alcohol. Okay, let us say C2H5. And there is a cross intermolecular hydrogen bonding between the water and alcohol, and it is going to be soluble because of the formation of hydrogen bonding. Actually, ionic compounds are soluble in water. Covalent compounds are insoluble in water. Condition: whenever covalent compound capable of finding hydrogen bonding with water, it is going to be soluble. You see how effectively the lecture is being delivered. You all find it and you can do the best. Okay, let's see intramolecular hydrogen bonding. What is the meaning of intramolecular hydrogen bonding? The hydrogen bonding that takes place within the molecule is called as intramolecular hydrogen bonding. You can see intramolecular hydrogen orthonitrophenol. So I will tell you how to draw this structure, bacho. Orthonitrophenol. So this is your benzene, hai na? This is your benzene. And whenever benzene has the OH, you can say phenol, right? This is your phenol. Whenever you have a nitro group with this, and this is going to be nitro group, and there is an intramolecular hydrogen bonding, that is what is called as orthonitrophenol. Because of this orthonitrophenol, it is molecule is so compact, so that it is going to be steam volatile. और एक molecule भी है ortho, meta and para positions of benzene. When the benzene is given with respective to 1 and 2, and this is known as a G2 position with respect to G1 is called ortho position. Stay tuned with our lag classes. So we are going to give you the best out of this. And you can say when 1 and 2 and 3, and that is G2 is meta with respect to G1. Okay, and this group 1 and 3, first position, second position, third position, fourth position, G1 and G3 are meta. So मैं क्या बोलना चाहता हूँ, 1, 2 is called as ortho, and it is 1, 3 is called as a meta, and is 1, 4 is called as a para. Alright, and also you can see example of intramolecular hydrogen bonding, or कुछ example चाहिए तो stay tuned here. And here salicylaldehyde. What is this salicylaldehyde? Ortho hydroxy benzaldehyde is called as salicylaldehyde. Ortho hydroxy benzaldehyde is called as salicylaldehyde, and we'll see more here. So this is your benzaldehyde, C double bond O and hydrogen, and orthohydroxy. So you can see the hydrogen bonding can be seen. This is what is called as salicylaldehyde or orthohydroxy benzaldehyde. You have intramolecular hydrogen bonding, and also you can see chloral hydrate. What is this chloral hydrate? Trichloroacetaldehyde is called as a chloral hydrate. So you can see 3 chlorines, and this is your aldehyde group, and this aldehyde group is hydrated. Actually, formation of hydrate for this aldehyde is going to be reversible, and equilibrium always lies in the backward direction. But due to intramolecular hydrogen bonding, this hydrate is going to be stable. It is an exception. So trichloroacetaldehyde is in the hydrated form, is called a chloral hydrate. Here you can see the chlorine is forming hydrogen bonding. It is an exception condition. In this condition, chlorine is forming hydrogen bonding. Okay, this is very, very important. So there are 2 hydroxy groups. Surprisingly, this is a geminal diol. Geminal diols are never be stable, but geminal diols in this case is going to be stable due to intramolecular hydrogen bonding. It is an exception, and it is a very important exception. Everybody follow this, and you can expect a very good questions from the NEET examination based on this. Bacho, Vivan and other students, Rushan, if you have any doubts, please let me know. That's fine. It's an exception here. So many exceptions are there. We are going to discuss. Stay tuned in the class, dear children. Hydrogen bond usually doesn't form hydrogen bonding due to the low electron density. But here it will. Chlorine in both orthochlorophenol and chloral hydrate form hydrogen bonding. But in the chloral, the chlorine do not usually form, but it can form because of this high electronegativity. Okay, and also hydrogen bonding dependence on the physical state of the compounds. So what is the dependence? If the magnitude of hydrogen bond depends on the physical state of the compound, rather I can say the physical state of the compound depends on hydrogen bonding. In the solid, it is going to be more than liquid state, and extent of hydrogen bonding is more in the solid state than the liquid state, than the gaseous state. And also you can see intermolecular hydrogen bonding. Few organic compounds like a non-polar are soluble in water in the polar solvent due to hydrogen bonding. Yes, like alcohol is soluble in the water, acetic acid is soluble in water, phenol is little soluble in water. Yes, this comes under this hydrogen bonding implementations. Amines are soluble in water. And also you can see these are the various examples that you can say. Carboxylic acid is soluble in water. Of course, during this hydrogen bonding, solvation also can happen. And also alcohol is soluble in water, bacho, right? And you can see solubility of ethane also. Yes, ethane is a hydrocarbon. Can you believe it? Ethane is little soluble. C2H2 is highly soluble in acetone due to hydrogen bonding, but not in the water because it is not ionizing. So C2H2 acetylene, because of this electronegativity, positive charge and negative charge is there, and this electronegativity difference makes it is going to form a bond with weak electrostatic force of attraction between oxygen of the acetone. This is a propanone is also called as acetone with ethane. You are going to see none of the above two has hydrogen bonding individually. So ethylene do not have hydrogen bonding, acetone do not have hydrogen bonding, but when these two mixes together, it is going to form hydrogen bonding. Fine, and it is an important in the solution aspect as well. So bacho, you can see solubility of alcohols in ethers. Yes, solubility order. Alcohol is more soluble as compared to the ether of comparable molecular masses, and it is due to the intermolecular hydrogen bonding is present in the alcohol. Intermolecular hydrogen bonding is not present in the ethers, right? And you can say that is the reason why you can say methanol is more soluble, ethanol is more soluble than dimethyl ether. Okay, and also solubility, intermolecular hydrogen bonding, you can see orthonitrophenol, you can say, and it is a chelate form. What is the meaning of chelate form? My dear children, if anybody knows, you tell me in the chat box. Chelation means something is formed as a ring within the molecule is called as a chelation. So this is the structure. Because of this hydrogen bonding, it forms a chelation. Because of the chelation, hydrogen not available for other molecule. So hydrogen bonding with water molecule is not permitted due to intermolecular hydrogen bonding of orthonitrophenol. As a result of this, what happened? The soluble hydrogen bonding is not there and it is not soluble. This is not soluble in the water. Can you believe it? Yes, it is not soluble. That makes this orthonitrophenol can be separated by steam distillation. It has a low melting point as compared to its corresponding para-nitrophenol. So when the phenol is nitrated, it is going to form orthonitrophenol and para-nitrophenol as a mixture. So this mixture has to be experimentally, practically separated by using steam distillation. When it is going for the steam distillation, orthonitrophenol is going to be more steam volatile because of the intramolecular hydrogen bonding, while in the para-nitrophenol you have intermolecular hydrogen bonding, it is not steam distillable. So there is a practical process called steam distillation can be used. So you can use this hydrogen bonding concept in chemical bonding, you can use in the organic chemistry, alcohols, phenols, ethers. Yeah, Akshita, hi, how are you? How are you doing? Yeah, Akshita, please like the session and the content I am giving you, please take a pen and paper, note it and we can do it. And if you have any suggestions about this lecture, if you have any topics that you want me to explain, you can mention in the chat box so that we can have a very good discussion between you and me, right? And effect of hydrogen bonding in their physical properties. So effect of hydrogen bonding in the physical properties. It affects the solubility, it affects the viscosity. Akshita, yeah, it affects the boiling point, it affects the physical state and it affects the acid base strength. Let us clearly see here. Because of the hydrogen bonding, solubility of the compound is increased. Simple. Because of the hydrogen bonding, viscosity is increased. H2SO4 is a liquid, but it is a thick liquid. It appears like a coconut oil. So that is due to extensive hydrogen bonding in the sulfuric acid. You know one thing, sulfuric acid is said to be a oil of vitriol. And you know phosphoric acid, because of this extensive hydrogen bonding, phosphoric acid appears to be like a syrup-like substance. So you can popularly call this phosphoric acid as syrupy phosphoric acid. And also you can see boiling point, due to intermolecular hydrogen bonding, boiling point is increased. Ammonia boiling point is more than phosphine. Water boiling point is more than H2S, hydrogen sulfide. And you can see physical state. Yes, water is a liquid, H2S is a gas. Yeah, Akshita, come on. And you can see acid base strength also. If the H plus hydrogen is freely available, it can give. If hydrogen bonding engages in the hydrogen bonding, so it cannot give. That is the reason why orthonitrophenol is less acidic than para-nitrophenol. Because in the orthonitrophenol, hydrogen atom in the phenolic group is trapped by intramolecular hydrogen bonding. Akshita, you have any doubt? And those students who are online, please, if you have any doubt in any aspect of the concept, you can just mention in the chat box so that I can explain that particular doubt by scheduling a special session and customized session to you. Okay, let's see here one more. And the hydrogen bonding, how it is related. boiling point is directly proportional to intermolecular hydrogen bonding. अगर intermolecular hydrogen bonding बढ़ते हैं boiling point भी बढ़ते हैं. Okay, और intramolecular hydrogen bonding, boiling point decreases. You can see elements boiling point. You see NaH3, you can see NaH3 and PH3, ASH3 and SBH3 and BiH3. These are all group 15 elements. They form the hydrates like this. You know, boiling point is directly proportional to intermolecular force. Boiling point is directly proportional to molecular weight. So, as molecular weight increases, the boiling point is expected to increase like this. This is the order of boiling point. But there is an exception, bachcho. The boiling point of ammonia is going to be, ammonia is going to be greater than a pH3. So, this is an exception. Among group 15 hydrates, pH3 is the one which is having the lowest boiling point. As this is lowest boiling point, it has a more tendency to evaporate. So, the most tendency to evaporate means is most volatile. Among this most volatile hydrate is going to be pH3. So, the actual order comes to be here pH3, ASH3 and NH3 and SBH3 and BiH3. Okay. So, this is the actual order of the boiling point. Are you getting or not? And these orders are very important when you attend the NEET examination में बहुत important है, very important. You never have a chance to rethink about this. And you can also see the boiling point comparison of group 16 also. You can see group 16 H2O, H2S, oxygen, sulfur, selenium and tellurium. And as we are expecting the boiling point here. What we are expecting? The boiling point supposed to be like this. As molecular weight increases, boiling point increases. But the thing is, exceptionally H2O is greater than H2S. So that because of the hydrogen bonding. That is the reason why H2O is a liquid, H2S is a gas. समझ में आ रहा है क्या? अक्षिता, okay. विवान त्रिपाठी, right. Now let us see. Similarly, you are going to see the halogen hydrates of group 15, 16, 17 are very important to extract a question from NEET examination. So, hydrogen fluoride and hydrogen chloride, you are this expected one, but it is a real one is going to be HCl and it is going to be hydrogen fluoride is greater than HCl. So, you can see the boiling point order comes like this. So, which of the molecule has the highest boiling point? A question. You can see this is orthonitrophenol, this is the paranitrophenol. Highest boiling point किसका होगा? जल्दी बताओ. This is orthonitrophenol, this is paranitrophenol. Orthonitrophenol has intramolecular hydrogen bonding. Paranitrophenol has intermolecular hydrogen bonding. In this intermolecular hydrogen bonding, you can say they have the more boiling point. I just want to say more boiling point. You can see intramolecular hydrogen bonding is come, intermolecular hydrogen bonding is come. So, due to intermolecular hydrogen bonding, it has a more boiling point. And you can see arrange the molecule in order of their boiling points. So, this is a water and this is alcohol and this is ether. So, extents of the hydrogen bonding. So, boiling point is directly proportional to extent of hydrogen bonding. That is very important. Okay. So, that I would say H2O is greater than, and it is going to be alcohol is greater than, and it is going to be ether. This is very, very important for NEET and other competitive examination. Water and alcohol is greater than ether. It could be any ether, any alcohol. It's a fundamentally it is true. So, bacho, you can see, why does ice float on the water? You take the ice and it is floating on the water. Why it is taking place like this? Because of the extent of hydrogen bonding present in the water, it is going to give rise a open cage like a structure which makes the solid water in the ice state, its volume is little increased, so that density is decreased. That is a key noteworthy point. Why does ice float on the water? In the water, each water molecule is extensively participating tetrahedrally with 4 intermolecular hydrogen bondings. 4 intermolecular hydrogen bonding gives like open cage structure, my dear children. So, because of this, okay, hydrate formations also seen here. Higher hydrates of hydronium ion with the formula H3O plus is given as H2O n times. Okay, so H3O2 plus is seen like this, H5O2 plus is seen like this, and this is explained on the basis of Arrhenius theory of acids and bases. Okay, so water forms a hydrogen bond, and also hydrate formation, effect of hydrogen bonding in the physical properties. We already seen the solubility, viscosity, boiling point, and also physical state and acid basis strength. Okay, bacho, that's good. If you have any doubt, please ask in the chat box. Please like this session, share with your friends, and subscribe to NEET Infinity Land YouTube channel, so that if you have any, if we are scheduling daily basis sessions, so you will be having updates based on this. Okay, and also hydrate formation increases the acidic strength, ease of removal of H plus, and basic strength, ease of removal of OH minus ions. So, which of the following molecules have highest acidic strength? And sulfur to hydrogen bond is weaker, and oxygen to hydrogen bond is stronger, and of course it has a hydrogen bond here. So, the acidic strength is going to be in this way. And also you can see this sulfur dioxide and bond polarities also we can see. We'll discuss some important orders we have to remember as far as the NEET examination is concerned. It's very important here. And the polarity of the molecules, let's talk about the polarity of the molecules. So, what is the meaning of the polarity? So, coming to the dipole moment. So, coming to this is about the dipole moment. When you see the hydrogen and fluorine, as we discussed here, hydrogen and fluorine. Fluorine is more electronegative, so that the electron is going to move more towards the fluorine, and it is going to be positive charge. So, there is a movement, so that movement is called as a dipole movement, because the movement is observed between 2 poles, and that is explained on the basis of mathematically this dipole movement is a vector quantity, is the charge on one pole, and this is the bond distance. This is what is called the bond distance. So, this is what is called as the dipole moment, and ESU centimeter is the unit, otherwise it is called as a dBi. Okay, 1 dBi is equal to 10 power minus 8 in ESU centimeter, and we are going to show you this dipole moment in the direction of the bond which is moving, and when it is moving in this way and 2 bonds are there, it is going to be a vector quantity. When this vector quantity is taken like this, A and B, and you are going to see and it is going to be the theta over here, and this as a dipole moment in this way, you have a dipole moment in this way. Resultant dipole moment is going to be root over nu 1 square plus nu 2 square plus 2 nu 1 nu 2 cos theta, 2 nu 1 nu 2 cos theta. Okay, if dipole moment, resultant dipole moment is going to be 0, that's said to be non-polar molecule. If resultant dipole moment is not equal to 0, you can say it is a polar molecule. Simplified version of the explanation of the total dipole moment is explained here. And you can see these are the molecules. When these molecules is seen with the dipole moment, you can discuss with this. Okay, some important orders to remember here in the dipole moment. Okay, dear all children, you can see here the dipole moment of this more electronegativity difference. You see, dipole moment is directly proportional to electronegativity difference between two atoms. Hydrogen to fluoride 1.78, chlorine electronegativity is a little decreased, bromine 0.79, hydrogen iodide. So that it is going to have more bond moment and it is going to have less bond moment. You understand? Clear? And moving ahead, now some important orders to remember here. CH3F, CCl3F. So you can see carbon and hydrogen dipole moment is towards the carbon, and fluorine and the dipole moment is in this way. Similarly, carbon to chlorine. And when you experimentally see the dipole moment of CH3F 1.81 dBi, and it is going to be 1.87 dBi. As you said, sir, dipole moment of this more electronegative should be more, na? But here it is going to be less. Why it is so? Anybody, it is an interesting topic to be discussed. You please let me know. Because of this, the lone pair of electrons that is present on this fluorine makes a little bit repulsion, makes it is a little bit repulsion. That is the reason why its value is coming down. And these values are there in the NCERT and it is very important. And let us see one more important thing. CCl3 chloroform, CH2 Cl2 dichloromethane and CH3Cl, it is methyl chloride. When you see these dipole moments, and these dipole moments, it is going to be 1.01, 1.59, 1.87. So the number of chlorine atoms increases and they are going to oppose their dipole moment, so that it is going to decrease the dipole moment. That is an interesting thing over there. And this is given in the part 2 NCERT textbook from this organic chemistry, haloalkanes and haloarenes. Hena beta? And one more important thing here, some more important, NH3 and NF3. NH3, NF3, here it is going to be fluorine, bacho. It is going to be fluorine, not hydrogen. Okay, this is about the fluorine. It is going to be fluorine. Okay, so actually what happened, NH3 and NF3, the dipole moment is going to oppose with the bond pair moment. That is the reason why dipole moment of NH3, dipole moment of NF3, dipole moment of NH3 is always greater than dipole moment of NF3. Because the reason, assertion and reason questions are also very important for NEET examination. The bond pair movement is opposed by nitrogen to fluorine bond movement. That is the reason. We want Triparty, come on, some important things. CH3F, CD3F. So now the deuterium to carbon bond. If you see this CH3F 1.847 and it is going to be 1.857. So the positive induct caused by the deuterium is more. Positive induct, deuterium is more than hydrogen. That is very important. Okay, that's the reason why CD3F is greater than CH3F. It's a super important one, and this kind of orders you need to know about the NEET examination. Don't worry, bacho, for the bond parameters, bond length, the bond angles, and other things, we can have a part 2 session as well. Okay, what is section formula? Which section formula you want me to teach? Shanta Mahat, be clear in your questions so that I can have a discussion based on that. कर सकते हैं? Yeah, you please be clear. You can ask me for pardon. Then you can see commonly used units for the charges. Charge on the electron. Charge on the electron, you can have 4.8 into 10 power minus 10 electron standard unit ESU, or 1.6 into 10 power minus 19 coulombs SI unit, CGS unit. We use both. For dipole moment we can use ESU also. So dipole moment in chemistry, when HCl bond is there, the bond is moving in this way, so that you are going to get a partial negative charge, you are going to get a partial positive charge. Okay, so that value is going to be 1.0 into 10 power minus 18 ESU centimeter is equal to 1 dBi. D stands for dBi. D stands here dBi. Okay, and dBi is actually the dipole moment is a vector quantity. It is shown by the tilde arrow mark, and it is going to be 1.03 into 10 power minus 18 ESU centimeter, or 1.03 dBi. And experimentally this can be calculated. Value of mu is equal to charge on the one pole between these two charges. It is the dipole moment is the product of the charge on the atom and the distance between two atoms in the bonding is called as dipole moment, and it is going to be, let D is equal to 1 angstrom units, let Q is equal to 4.8 into 10 power minus 8. So 1 angstrom unit का मतलब क्या इसका? It is going to be 10 power minus 8 centimeters, mind it. So that I could say this is going to be 1 ESU, 1 dBi is equal to 10 power minus 18 ESU, right? Yeah, Shanta. So what ratio does the point x3 divide the line joining with point A 8 minus xb 2 5? Also find the value. My exam is tomorrow. That is a mathematics question. It is a NEET YouTube channel. So you could ask that question in the JEE mathematics class. So the mathematics teacher is going to ask this question. He is going to answer you. Okay, Shanta Mahat, and apologies, I am not solving your question. Okay, those who are in online, please ask a question related to the current context so that we can have a discussion, right? Okay, now it is going to be 1 dBi is equal to 1 into 10 power minus 18 ESU centimeter. So mu is equal to 4.8 dBi here, and values of dBi that we already discussed here. So this dipole moment can help you to analyze the percentage of ionic character. So this percentage of ionic character is equal to observed dipole moment upon calculated theoretical dipole moment into 100. Okay, JEE channel. Okay, you can just see JEE, infinity line JEE, there you can see Shanta. So talking about observed dipole moment and experimental value. Experimental value, you have to do the experiment and you will get it in the question you will be given. And observed dipole moment formula इस हिसाब से आप calculate करना पड़ता. And the theoretical dipole moment is 100% ionic compound. Okay. And the percentage of character in the covalent bond. So the percentage of ionic character is equal to, it is given from the Hanny-Smith, and 16 into difference in the electronegativity. Everybody please take a pen and paper, write the formula, plus 3.5 into difference in the electronegativity square, and taken that value into the percentages so that you are going to get the percentage of ionic character. and also so gives only approximate value of percentage ionic character, not exactly. Okay. Yeah, yes it is. Now you can see here you have various kinds of the intermolecular forces are there. So we will be discussing these types of intermolecular forces and the metallic bonding and also the other parameters like bond length and bond energy. So my dear children, we are done for today, and we'll meet with more stuff in the upcoming session. Stay tuned. Please like the session, and please share this session with your friends and subscribe to NEET Infinity Learn channel. Thank you. Signing off, Suresh. Thank you. Signing off, Suresh, Faculty of Chemistry. Bye-bye.